Hi everyone, today is our next video, okay, and it is the fourth video of our channel, that is Science and Mathematics, and this is based on mathematics. The previous video we were learning on metals and non-metals was very important, so you can also check the videos for metals and non-metals in my channel's playlists. Okay, and now the other thing I told you in the previous video, that I will also make a video on the extraction process, which is very much important for class 10 as well as class 9. So today we will discuss on mathematics chapter, that is triangles and the congruency axioms, that is the test of congruency, as well as the midpoint theorem. It is very important for class 9. So let's start our video. First of all, that is, what is congruency? Okay, congruency is what when two triangles are congruent. Okay, when we are telling that triangle ABC, it is the congruent sign, triangle DCF, then what we are referring to? We are referring to that their interior angles, each interior angle is equal to the respective angle of the other triangle. Suppose angle A will be equal to angle D in angle DCF, or the example, any example you take. Okay, all the angles, each angle will be equal to the respective angle of the other triangle. Okay, and also the three sides will be also equal to the respective sides of the other triangle. Here I have only given an example that if we say that this triangle and this triangle are congruent, then we are referring to those of the points. Okay, now this angle, let me take a different color. This angle and this angle will be equal if this triangle and this triangle are congruent. This angle and this angle will also be equal, as well as this angle and this angle, and this side will be equal to this side. Okay, this side will be equal to this side, this side will be equal to this side, and this side will be equal to this side. Okay, now we have understood that what is congruency and what we refer to by the term congruency. Okay, now let's move on to our next slide, that is the axioms of congruency, that how can we prove what are the tests of congruency, or how can we prove that a triangle, two triangles are congruent or not. So this is the axioms of congruency. So the first axiom is SAS, that is the side angle side. Okay, now in this we can understand by the name that this side and this angle and this side. Okay, like we can understand that this side and their middle, or the included, it is the included among these two sides. Suppose this is a side of a triangle and this is a side of a triangle, and this is a triangle. Okay, and this side, that is this side, and this this angle, if equal to this side and this angle, then these two triangles can be said to be congruent. Okay, now next axiom is ASA. Here we can also understand by the name that angle side. Therefore these are the two angles, like this. Suppose this is a side. Okay, now this angle and this angle, this is a triangle. Okay, now this included side, here have been mentioned, which we will learn in the next slide. Okay, now next axiom is EAS. I hope that you have not learned this axiom. Okay, but this SAS, AAS, these axioms are very common, but AAS, that is the angle side, is I think it will be uncommon to you, because this property is not mentioned in every books. Okay, it is mentioned on a particular some particular books. Now AAS is angle side, that is this angle. Suppose this is a triangle. Okay, now this angle, and this side, okay, if equal to any corresponding parts of that any other triangle, then we can say that this is both the triangles are congruent. Okay, now our next axiom is SSS. It is very common, it is also very easy. Okay, SSS, that is side. Now next is RHS. Here RHS is only applicable in right angle triangles. Okay, now you can see that what is the full, it is the abbreviated form. It is the abbreviated form, and right angle hypotenuse side, it is the full form of RHS. Okay, now here we can understand that hypotenuse is only there in right angle triangle, and also right angle means 90 degree, it is also there in right angle triangle. Okay, now all these axioms we will learn in a descriptive manner in our following slides, so let's do that. Now this is our first axiom, that is SAS. Okay, now what is SAS? You can do this, go over this definition, but I don't like that going over or memorizing the definition. You try to understand that what is the axiom referring to, or what is the axiom's relation with the congruency. Okay, you try to understand that first. I don't rely upon the these definitions. Okay, which in examination you may have got questions like this, but you can, if you understand one thing, I am advising you. Okay, if you understand properly, understand a theorem, or understand a line properly, or understand this concept, you can also say, then you will be easily able to write it in your own words. Okay, so try to do that. So here, for the sake of you, I will read this called this definition, is called blah blah, this called definition. So I will read that. If the two sides are included angle of one triangle. Okay, now as I was telling that this side and this side are equal, and this side and this side are equal, and if this included angle and this included angle are equal, then we can say that triangle ABC congruent. Congruent sign, you have to remember that this is, sorry, okay, this one is the congruent sign. You have to remember this. Okay, now it is the property that you have to remember that no other angles will be included, only the sides which are given equal. Suppose this side and this side and this side and this side, then this included angle, if given, is equal, or you can prove that those angles are equal, then only we can say that these triangles are congruent. Now you may have a question that if this side, if we take this side or this side, can it not be equal? But yes, my answer will be yes, but the angle should be this included angle, and this side and this side equal, then this included angle. This included angle means between two sides the angle which is there in the triangle. Okay, this side, this side. Suppose I am marking it as x and this y. Okay, now this x and y, this angle A. Okay, now this angle A should be between x and y, and in other triangle, suppose I am marking it as W and Z. Okay, now in W and Z it is B, angle B. Now it should be equal to angle B equal to angle A. Okay, and now side W equal to side X, and then side Z equal to side Y. Then only we can say, because the angle is included between the two sides, that is in triangle ABC, we can say that BC and the two sides, if we are taking BC and then AB, then the included angle will be this. Okay, angle B. Okay, like this. So let's move on to our next axiom, that is ASA. Yeah, got it. So we will learn now the ASA axiom. So if two angles and the included side of a triangle equal to the respective two angles and the included side of the other triangle. Okay, now like those, it is very much similar to SAS. Here you have to get the included side, and whereas in SAS you have to get the included angle. Like this is the angle, this is the angle, and this is the angle, this is the angle. Okay, this angle is equal to this angle, this angle is equal to this angle, and if this side is equal, then only we can say that triangle ABC congruent triangle DCF. Okay, if this included side, if two angles are given equal to this respective angles, and if this side is given equal to this side, then we can't say that these triangles are congruent. Okay, now let's next move on to the next slide. We can see that this side is given by the AAS. Okay, by AAS we can say that these triangles are congruent. But when you are trying to you are using the ASA axiom, you have to use only the included side. Okay, if you are thinking about the ASA, not that one, the AAS, okay, then it will be a total misconception. So please try to check it out. Okay, now next, this is a very important AAS. You have not learned it earlier. In earlier classes it was also not there. Okay, now it is AAS axiom, that is the angle side. Now what is this angle side? If two angles and a non-included side, okay, as I was telling that if you are thinking that this time will not be congruent, okay, that time I was saying wrong, it can be proved to be congruent by the AAS. Okay, but if you are thinking about ASA, and suppose you know that we have to write about that what type of axiom we are using to prove the triangles congruent, then if you are writing ASA and you are applying AAS, then it will be a totally wrong answer, or you cannot get marks, full marks in that question. So you have to remember this. Okay, now it is the most important word is non-included side. Suppose this angle and this angle are equal, this angle and this angle. Okay, now this is not an included side, so but by AAS axiom we can prove that this triangles are congruent. So let's move on to the next axiom, that is SSS. So what is SSS? SSS is side axiom. If three sides of a triangle is equal to the if three sides of the triangle is equal to the respective three sides of another triangle, then we can say that those two triangles are congruent. Okay, now suppose this side, and this side, and this sides are equal, then by the SSS axiom we can say that these triangles are congruent. Okay, now RHS axiom. So what is this RHS axiom? I told you that it is only applicable in right angled triangle, because its full form or its full name we can understand that it is right angled hypotenuse side. Okay, it is the full form. So now let's understand that what is RHS axiom. Now if one side, suppose one side, that is this one, not this one, sorry, one side, suppose this one. Okay, and the this side is equal to this side, and this hypotenuse equal to this hypotenuse, and this angle is 90 degree. Then we can say by RHS congruency or RHS axiom that this triangle and this triangle are congruent. Okay, this is the hypotenuse and this is another side. If we are given this side, then we can also say by that it is the another side. This side or this side, any of those two another two sides other than the hypotenuse is given equal and that is 90 degree, okay, then angle is 90 degree, that is right angle triangle, then we can easily say that those two triangles are congruent by the RHS axiom. Okay, now let's move on to the most important thing, midpoint theorem. It is very much important, and class 10 students can also see this, that what is midpoint theorem. But before that, I want to give you a slight concept about the quadrilaterals as well as some basic concepts and formulas of quadrilateral, okay, as well as polygons. Okay, so let me open that slide and then I will make you understand the midpoint theorem. So yeah, I got this slide, and now I will give you a slight concept about the quadrilaterals. We will continue this on in our mathematics section, and we are going with the metals and non-metals in science section. Okay, metals and non-metals, then I will upload the last video, that is the extraction. I have made 4 videos of the metals and non-metals. You can check it out. So for this, you have to subscribe my channel, Math and Science. Okay, now please first of all subscribe. Okay, please subscribe my channel. Now we will discuss, and most important thing I wanted to tell you today, that there is also my Google Classroom, okay, where you can also get into, okay, or you can also take you can get enrolled. Okay, I will give you the code in the description link, description box. Okay, but first of all you have to subscribe. Okay, and there in Google Classroom you will get many Google Forms test. The test I was talking about at the introduction video. In the introduction video, you will all get that in the Google Classroom, but you have to join my Google Classroom to get those tests. And also I will give you the study materials, these important slides or the presentations I am making. Okay, I will give you in that Google Classroom only. Okay, you can join. I will give the code of Google Classroom in description box, but you have to first subscribe. Okay, then I will only admit you. Or you can also simply text me your email ID in the comment section, then I can invite you from the Google Classroom. So now I will give you some basic concepts. I will give you some basic concepts of quadrilateral. Okay, here is our first video of quadrilateral. Okay, I am giving a slight concept because in next video we will understand the quadrilaterals as well as different theorems, as well as of different theorems of circles as well we will learn. Okay, now let's start with our polygons. So what are the polygons? They are bounded polygons. About polygons are the area, you can also say they are the figures that are bounded by line segments, and examples at this you can view. Okay, these are the examples of polygon. Polygon is what called polygon is a closed bounded figure, closed figure bounded by line segments. Okay, now what is convex polygon? Convex polygon is what? In convex polygon, all angles are less than 180 degree. Okay, in convex polygon, all angles are less than 180 degree, and all the diagonals of the convex polygon, you can see here the example of the figure is. Okay, in convex polygon, in convex polygon, all the diagonals must be in the interior of the figure or the polygon. Okay, of the convex polygon, the diagonals are all in interior of the figure. And now let's do our concave polygon. These are the two types of polygon. So in concave polygon, at least one angle is more than 180 degree. So we can understand that at least one, we can also say that at least one angle is a reflex angle, that is between more than 180 degree and less than 360 degree, we can also say. And the diagonals may be out in the exterior of the figure in concave polygon. Okay. Now we have understood concave polygon, and we have understood also its property. Now here you can view the example of convex as well as concave. Here you can see the convex as well as the concave polygon examples, like how this looks like. Now let's move on to the properties of a regular polygon. Okay, so what are the properties of a regular polygon? Now we will understand. Okay, 1 minute. Now the properties of a regular polygon. A regular polygon is always convex. Okay, it is always a convex polygon because in a regular polygon all the sides as well as the interior angles are equal, that I have written here. Okay, all the interior angles as well as sides are equal. Okay, and all the exterior angles are also equal. These are the properties of regular polygon. Now some basic formulas. Okay, now the first formula, that is sum of the interior angles of n-sided polygon is 2 into n minus 4 into 90 degree. Okay, now in some books it is also written that n minus 2 into 180 degree. It is the same. Okay, if you divide it by 2, okay, if you divide it by 2, and first of all in 2n minus 4 you have to take 2 as common. Okay, if you take 2 as common, then what it will be? N minus 2. Now if you divide it by 2, now it is given that into, you have to take from the whole expression. Okay, multiply. Now if you take 2 common and if you check it out, okay, now what you will see that it will be n minus 2 into 180 degree. Okay, it is only the thing that we are dividing this expression, that is 2n minus 4, we are taking common only 2. Okay, n minus 2, and this 2 we are multiplying to 90 degree. Okay, we are only multiplying this to 90 degree. So what it is becoming? It is becoming n minus 2 into 180 degree. So it is very simple. It is nothing to worry about. Both the theorems or both the formulas are correct. Okay, now let's learn our next theorem, that is sum of all exterior angles of n-sided polygon is 360 degree. Okay, now all the exterior angles, that is means suppose this is a polygon. Suppose I am drawing a pentagon, then these are the exterior angles, this exterior angle, this is the exterior angle, this is the exterior angle. Then what will happen, that all the exterior angles of the regular polygon will be equal. You have to remember this term, that is regular polygon, not all polygons. Not all polygons. Okay, only these are applicable for the regular polygons. Now our next theorem. 1 minute. Yeah. Now next theorem, that is each interior angle of the regular polygon is 2n minus 4 into 90 degree divided by n. Okay, now this is only applicable for each interior angle if we divide the sides. Okay, the sum of the interior angles, if we divide it by side, then we will get each interior angles only in case of a regular polygon. But the sum of interior angles of an n-sided polygon, it is applicable for all types of polygons. Okay, 2n minus 4 into 90 degree or n minus 2 into 180 degree. It is applicable for all the polygons. Okay, not particularly the regular polygon, but this each interior angle of regular polygon, if we divide the sum of all interior angles by its side, okay, its length of side, so not the length of side, the number of sides. If we divide it by the number of sides, n here denotes what? N here denotes the number of sides, and here denotes the number of sides. Okay, now each interior angle, we have understood that it is only applicable for the regular polygon. Okay, now next property is the each exterior angle of a regular polygon. Okay, you have to give importance, or you have to concentrate on this term, on this term, in these two theorems, in this. Okay, in this two theorems, you have to concentrate that the regular polygon, if we divide the exterior angle as well as the interior angle, okay, exterior angle is always 360 in any type of polygon, and if we divide it by the number of sides, then you will get each exterior angle only in case of a regular polygon. I will also give you some practice sums in this slides, which I will give you as well as show you the solution. Okay, now let's move on to the next slide. Now, polygon now here we will learn that what are the states of polygons. Okay, name of the polygons with the respect to their number of sides. You can view this image clearly, I hope. This is triangle, this is quadrilateral, this is pentagon, this is hexagon, and now we'll learn that what is this. These are the names according to their sides, their number of sides. Okay, now first, there is polygon with 3 sides is called triangle. Polygon with 4 sides is called quadrilateral. Polygon with 5 sides is called pentagon. Polygon with 6 sides is called hexagon. Polygon with 7 sides is called heptagon. Polygon with 8 sides it's called octagon. Polygon with 9 sides it's called nonagon. And polygon with 10 sides it's called decagon. Now this the name of the polygons with the respect to their number of sides. Okay, now we will again move to our midpoint theorem. Okay, which we were doing. Okay, I give you a slight concept over the polygons and the quadrilaterals, and in next video I will give you a total description of quadrilaterals. Okay, and also the properties of the parallelogram, rectangle, all the properties. Okay, and also a new diagram we are knowing about, that is kite. Okay, so let's move on to our midpoint theorem. Let me open that slide. So we have completed up to RHS axiom. Now we will do the midpoint theorem. So we will first understand that what is this midpoint theorem. Okay, the line joining the two sides of a triangle is parallel to the third side. Okay, suppose here you can see this side. Okay, here you can see this side and this side. Okay, it will be parallel. In case of a triangle, by midpoint theorem we can prove this. Okay, and it is also, and this is equal to the half of this. Okay, half of this third side. These are the two points we can prove by the midpoint theorem. Okay, this is what I have written in this para. You can see this. Okay, I'm giving you time. You can also see this. So let's move on to our next slide. It is how to prove the midpoint theorem. It has been explained in our next slide, and this is the diagram I have mentioned. I will draw and shown with the example. Okay, I have proved this, how this is happening, why this will be parallel, and why this will be half of the third side. Now this is, I have written it in the copy. Now, suppose you are given that this side, the midpoint is E. 1 minute. This midpoint is E over this side. Okay, and there is also midpoint over AC, that is F. Okay, now next what you have to do, you have to do a slight construction. Okay, now you have to extend this line segment, that is EF, that is this one. You have to extend it to G. Okay, you have to extend it to G only. Okay, now what you have to do is, by making this construction, you have to keep in mind while making this construction that this side, this EF should be equal to FG. Okay, then only you will be able to prove by, you have to do this construction. Okay, since it is a midpoint, it will be okay. Now if we check out the triangle AFE, okay, this triangle AFE and this triangle CFG, okay, these two triangles we will consider first of all. Then angle CFG, this angle and this angle will be equal because they are vertically opposite angle, and this is the midpoint of side. Midpoint, if we take a side like this and this is a midpoint A, then what it will be, suppose this is a side BC, then what it will be, this side, that is this BA will be equal to AC. Okay, this is the property of a midpoint only. Now this side will be equal. We are considering this triangle and this triangle, this side and this triangles, this side will be equal. Okay, now and also this side and this side will be equal because this is a midpoint F and F here will be equal. Okay, now by this we can prove by SAS that this angle and this angle, we found that these are equal. This side and this side we found that we equal, and this side and this side. So how we can prove that these triangles are congruent? By SAS. We can easily prove that these triangles are congruent. Now after getting proved that these triangles are congruent, what can we say? That all the angles as well as all the sides of a triangle are both the triangles are congruent. So now here I have written only this, that this triangle and this triangle are congruent. Okay, now next, that is AEF. What is AEF? This angle and this angle, that is FGC. Okay, these are equal, we can see, because we have proved that these are the congruent triangles. So here what we can see, that these are the alternate interior angles. Okay, if you view like this by vertically, this image by vertically, okay, what you will find that these are the alternate interior angles. Okay, now here what we can see, that these are the alternate interior angles, and we can also say that this angle and this we can also say that this angle and this angle are also equal because the triangles are congruent. We call it the corresponding parts of a triangle. Okay, it is called by the corresponding parts of a triangle. Okay, now if you see it properly, then these are the alternate angles. Okay, now we can easily say that this is AC is a transversal, and this line and this line are parallel. Can we see that? Yes, we can say that, because these are the alternate interior angles, and we know that when a transversal is drawn through two parallel lines, only then the alternate interior angles are equal. So here we can see that how the congruency can be used in also the midpoint theorem. So how the congruency is very important again in mathematics. But this whole practical geometry chapter, geometry as well as practical geometry, congruency is very much important again. Now we can say that this side, that is AE, that is CG, is parallel. We can say that easily. Now we can also see that this side is equal to this side because E is the midpoint. Okay, now can we say that CE, that is called the that is GC equal to BE. We can say because if GC equal to CG equal to AE and AE equal to BE, then obviously CG equal to BE. Okay, because E is the midpoint and AE and BE should be equal, must be equal. Okay, BE and AE must be equal. Okay, now what is about GC is equal to BE, like this. Okay, now we can say that if AE parallel GC, then AE parallel GC, then GC will also be parallel to BE. So can we say that this quadrilateral, that is BCGE, is a parallelogram because the opposite sides are parallel as well as equal, and this side will also be parallel. So here, hence, we have proved that if this is a parallelogram, we are getting, and this side will be parallel. Okay. Now what we are getting, that it is a parallelogram. Okay, now you are getting it is a parallelogram, so this side and this side will obviously be parallel as well as equal. So, and EF is the half of the side EG or GE, you can say. So can we say that EF equal to half of BC, since it is, first let me write that, 1 minute. Okay, first we will see that EF equal to half of EG. We can write because F is the midpoint. Okay, now we know that EG equal to BC. Okay, now we will only replace this EG with the BC. Okay, so what it will be? It will be EF equal to half of BC. So hence it has been proved that it is the half of the third side, and okay, it is the half of the third side and equal half of the third side, as well as it is parallel to the third side. So thank you for watching this video, and we will see you in our next video. So for that, please stay safe and healthy. Thank you.